Hello everyone, welcome back to Code to Enhance Learning video series. In this video series, we are creating projects that integrate advanced physical computing with the world around us using Arduino Uno. Welcome to the next video of the series Measure Body Temperature. In the last episode, we learned how to create a prototype of Home Automation Advanced project, a Bluetooth-based home automation system which allows users to wirelessly control household devices through smartphone, tablet, and making their daily life easier. If you missed any part or want to revisit previous videos, you can find the entire series in our YouTube playlist. Be sure to check it out and continue learning at your own pace. Today we are going to build an exciting project, a project to measure body temperature. The purpose of this project is to develop a simple and efficient body temperature measurement system which aims to provide an easy to use device that measures body temperature in real time, displaying it for immediate reading. Such a system that can be useful in variety of settings including healthcare, home monitoring, and educational environments, offering a practical tool for tracking body temperature accurately and cost effectively. Let us see what is today's objective. In this lesson, we will make a project to measure temperature using a LM35 sensor and display it on LCD 16:2. For this project, we need following components. Arduino Uno acts as our main microcontroller to process temperature data from the sensor. LCD display to display the measured temperature in real time with fewer connection thanks to I2C interface. Breadboard provides a platform to connect components without soldering. Temperature sensor measures body temperature in Celsius with high accuracy. Jumper wires connects components for the data transfer and power. LEDs provides visual alerts indicating green for normal and high for the red. USB cable uploads code to the Arduino and supplies power during operation. For our project, we are using LM35, which is an integrated analog temperature sensor. Its electrical output is proportional to degree centigrades. LM35 sensor does not require any external calibration or trimming to provide typical accuracies. LM35 has 3 pins, negative, positive, and a signal pin. Now that we have reviewed the components and their importance, let's proceed to connecting them and building our circuit. Let's get started. Let's start with our connections. So here I have all the components required for our connections. So let's start with the breadboard and the Arduino. First what we have to do is we have to take the power pins on our breadboard. So I am connecting 5 volt and ground on the breadboard's top pins. So here I am connecting it like this. So now my power is ready. Let's start with our LM35 sensor. So here we have seen it has 3 pins. So let's connect it. Then we have to connect the first pin of LM35 to power pin. Then next pin to our ground pin and signal pin to signal pin. So for us signal pin is A0, so we'll connect it to A0 of our Arduino board. So here I am connecting it to A0. Now that we are ready with our LM35, let's start with our 16:2 I2C LCD. So here you can see we have I2C module soldered to our LCD, and for I2C we have 4 pins to connect. So let's start the connections. Here we have ground pin. So let's connect ground to ground. Then VCC pin to VCC. Next we have is SDA pin, which we have to connect to A4 and SDL pin to A5. So let's finish the connections. I'm connecting it. A4 and A5. So here we can see we have A4 and A5. And now I'll place it like this so that my values will be visible to me. Then next we need two LEDs. One is red and other one is green. So I'm using them. I'll place them first on the breadboard. And now we know the connections where we have to connect the anode and where we have to connect the cathode. So let's start. We'll connect cathode to ground. Connect it to the ground. And green LED we have connected it to the pin number 10. So we'll place it in pin number 10. And red LED I think we have connected to pin number 9. So pins you can change according to your usage. So I have connected red LED to pin number 9. So I am connecting it here. And next is ground pin or cathode pin of LED to the ground. So now I am done with my connection and let's move to the coding. As our circuit is ready, let's start with coding. For coding, we are using mBlock software as other projects. We will walk through the step-by-step process to code our project. We will guide you through each part to help you bring your project to life. So let's dive in and start coding. For coding, we have two parts. One is device code, that is code for our Arduino board, and then one is for sprite code. So let's start with the coding part now. Here we can see that for the programming I have opened the mBlock software. Let's add the device. So we are not working with CyberPi, so I'll close this. I'll delete this and then I'll add our Arduino Uno board. So here you have to select it like this and then you have to click on OK. So we can see that Arduino Uno got added. Now we need two extensions for our project. So let's go to extensions and we need upload mode broadcast. So I'll add this and then we need one more, that is our LCD I2C. So for that what we have to search is LCD with caps I2C, the first option, or if you are not getting, you have to type the whole name LCD I2C LCD. So I'll add this extension over here and then let's start with our coding. We will be coding it in upload mode. So I have selected here upload mode. Let's start. So what we want to do is we want our code should start when Arduino Uno is up. So for that I'll go to I'll go to event and I'll select this option, that is when Arduino Uno starts up. Next is we have to start our LCD. So I'll go to LCD and I will get the first block, that is I2C block. So now next what we need is we have to send the message what we are reading on our analog pin. So for that we will go to upload mode and we will select this block, that is send upload mode message with value. The value what we want to share or send is what we read at our analog pin. So I'll go to pins and here we can see that we have to get the analog pin. So I'll select that read analog pin and we have connected our sensor to A0, so no need to change here. Then we have to forever keep reading the value. So for that and display it on the LCD, for that we need forever block. So I'll go to control and I'll drag the forever block. Now let's do for the LCD. What we have to do is for LCD on the first line we have to show the temperature. So for that I will get this block and what we need is we have to display the temperature. So for that we will use the join block and here I will change this apple to body temp and I will use hyphen and I'll use space, and then in place of banana we have to
at the temperature or the value we are reading. So for that, what we have to do is we'll get the division block from operators. We'll place it here, and I'll go to pins once again, and I'll get this read analog pin in, and I'll put it in division block, and then I will divide that temperature by 2, and this whole block I will put in the LCD. Okay, now next is what we need is we have to show some alerts with the LEDs. So for that we have to use the if then block. So I'll use the if then else block, and then we have to check if temperature is less than 43. So what we will do is we'll go to operators and we'll get the less than block, and we need it less than 43, so I'm keeping it here 43. And what we have to compare is what we are reading. So this division block I will put here, and then what we have to do is we have to, if temperature is greater than 43, so we have to turn on our red light or red LED. So for that, what I will do, again I'll go to pin, and I will set the digital pin 9 as high, and that time our green LED should be off. So I will set the digital pin 10 to low. Okay, and otherwise if our temperature is in normal range, in that case what we have to do is we have to put our pin number 10 high. So I will again get this, I will change this to 10, and my temperature means my LED will be on, and in that case my LED which is connected to pin number 9 should be off. So I'll put it low. So that this is how we are done with our device code. Now let's go to sprites code. You can change the sprite if you want to. I'm keeping this as panda only, and here I will add the extension of upload mode broadcast. And here what we need is whenever I receive the temperature message, what I have to do is I want my panda should say that. So what I'll do is I'll go to looks and I'll get this say block. And here what I want my panda should say is whatever message it is received. So that's what is our coding for now. This is very simple code, you can try it.
Here you can see that when I hold the temperature sensor, it says body temperature 28 and green LED is on. So that's the working of our project.
In today's video, we successfully demonstrated how to measure and display body temperature using LM35 sensor, Arduino Uno and I2C16x2 LCD. The inclusion of LEDs for visual alerts enhances the system's usability, making it easy to understand the temperature status at a glance. This simple low-cost solution can be used for basic health monitoring and can be expanded with additional features for advanced applications. In the next video of this series, we will explore how to build a noise detector using Arduino Uno and a sound sensor, creating a system that can monitor noise levels in your environment. Stay tuned.